Hello everyone. Instant noodles have become one of the most popular and widely consumed foods in the world. With their quick preparation, affordable price, and satisfying taste, it's no surprise that global demand for instant noodles has reached a record high of 121.2 billion servings per year. Countries like China, Indonesia, and Vietnam lead the way in consumption, but instant noodles have gained popularity across every continent, from Asia to North America and even Europe. But have you ever wondered how those perfect curly noodles make their way from the factory to your bowl in just a few minutes? In this video, we'll take you behind the scenes to explore the fascinating process of producing instant noodles in modern factories. Let's dive in. The foundation of instant noodles lies in firm and elastic texture. Water is used to hydrate the flour and activate the gluten, while salt strengthens the dough and enhances the flavor. A key ingredient that sets instant noodles apart from other types of noodles is kansui, an alkaline solution containing potassium carbonate and sodium carbonate. Kansui gives the noodles their distinctive yellow color and chewy texture. Vegetable oil is often added to prevent the noodles from sticking and to enhance the flavor. Once these ingredients are measured and inspected, they are transferred to large industries, which is crucial for creating noodles that are firm yet elastic when cooked. Kneading continues for approximately 15 to 20 minutes, depending on the specific recipe and the type of flour used. The goal is to achieve a dough that is smooth, elastic, and slightly firm to the touch. Overmixing can lead to tough noodles, while undermixing can result in noodles that break apart during boiling. The temperature and humidity in the mixing area are carefully controlled to ensure consistent results. Too much moisture can make the dough sticky and difficult to handle, while too little moisture can cause the dough to crack and become brittle. Once the dough reaches the desired texture, it is ready to be shaped into thin sheets and cut into noodles. After the dough has been mixed and kneaded, it is transferred to a series of rolling machines. The rolling process involves passing the dough through a series of steel rollers to create thin, even sheets. This stage helps align the gluten structure, giving the noodles their characteristic chewiness. The rolling machines gradually reduce the thickness of the dough from approximately 5 millimeters to around 1 to 2 millimeters. The thickness of the final sheet depends on the type of noodle being produced. Thinner sheets result in delicate, fine. It helps the noodles hold their shape better during boiling and enhances the overall texture. Curly noodles also trap more broth and seasoning, providing a more flavorful eating experience. The freshly cut noodles are collected on conveyor belts and sent to the next stage of production, steaming and pre-cooking. Before drying, the noodles need to be partially cooked to help them retain their structure and improve their ability to absorb flavor. The freshly cut noodles are passed through a high-temperature steam tunnel, where they are exposed to steam at approximately 100 degrees Celsius for 1 to 2 minutes. The heating process also helps the noodles hold their shape during the drying and frying stages. Steaming is an important step because it partially cooks the noodles, reducing the cooking time for consumers. Without steaming, the noodles would need to be cooked for a longer time before they could be eaten. The controlled heat and moisture from the steam help maintain the integrity of the noodles, ensuring that they remain firm and chewy after boiling. After the noodles have been steamed, they move on to the cutting and molding stage, where they are shaped into the familiar form seen in instant noodle packets. First, the long sheets of steamed noodles are fed into a precision cutting machine, which slices them to a specific length, typically around 30 to 40 centimeters, depending on the product type. The cutting process is carefully controlled to ensure uniform size and texture, which helps the noodles cook evenly when prepared. Once cut, The noodles are transferred to a molding station, where they are carefully placed into square or circular molds. These molds give the noodles their compact shape, making them easy to pack compressed to create the classic curly texture. This step is important because the wavy shape helps the noodles retain broth and 160 degrees Celsius. The hot oil rapidly evaporates the moisture in the noodles, reducing the water content to around 3%. The frying process takes only 1 to 2 minutes and gives the noodles a crisp texture. The oil also adds flavor and richness to the noodles, enhancing their taste when cooked. In the air drying method, the noodles are passed through drying chambers where hot air circulates around them. The temperature in the drying chambers is maintained at around 70 degrees Celsius to 90 degrees Celsius. The drying process takes longer, typically 30 to 40 minutes. The flavor of instant noodles comes from the seasoning and soup base that accompany the noodles. The seasoning packets are prepared separately, using a combination of salt, sugar, soy sauce powder, dehydrated vegetables, meat extracts, and spices. The seasoning mixture is carefully blended to create a balanced flavor profile. Flavor enhancers such as monosodium glutamate, MSG, and yeast extract are often added to boost the umami taste. Some premium products, after the noodles and seasoning packets are ready, they are assembled into the final product. Noodles are portioned into individual servings and packaged in plastic cups, plastic film, or foil pouches. The packaging is sealed to protect the product from moisture and contamination. Factory packaging machines can produce up to 600 packets per minute, ensuring fast and efficient production.
Fast forward to September or October, and a new wheat growing season kicks off as the weather cools down after the scorching summer days. Most farms in the US plant winter wheat. Different wheat varieties have different growth cycles, typically taking 120 to 150 days to reach full maturity. Kansas, with its mild winters, warm summers, flat plains, and moderate rainfall, offers the perfect natural conditions, making it the largest wheat-producing state in the country. The wheat growing process begins with selecting the right seeds. Farmers usually purchase wheat seeds from reputable seed companies. Before doing so, they check all the conditions of the seeds, including germination rate, origin, nutrient analysis, and field testing. The wheat seeds are treated with chemicals to protect the crops from threats like pests, mold, and other adverse factors during the germination and early growth stages. After each season, the soil used for growing wheat becomes compacted and overgrown with weeds, reducing its looseness. Before planting wheat, farmers must till the soil to loosen it up and create ideal conditions for wheat roots to grow deep into the ground. Tractors with plows are used in the fields, following predetermined rows, with plowing depths typically ranging from 20 to 30 centimeters to ensure the topsoil is thoroughly loosened. Once the soil has been tilled, the prepared seeds are loaded into the compartments of a seed drill to continue their journey across the field. As the machine moves across the field, the wheat seeds are automatically dropped into the soil through holes in the seed drill. Modern seed drills can plant evenly, quickly, and accurately over large areas. After sowing, wheat requires careful attention, particularly in providing adequate water and nutrients. Many wheat farms are equipped with automated irrigation systems. One of the most common systems used in wheat fields is the sprinkler irrigation system. This system consists of water nozzles installed along pipelines, which create water sprays or small showers that mimic natural rainfall. Additionally, there are high-pressure sprinkler systems that feature a central water pipe capable of rotating 360 degrees, allowing for uniform water distribution over the field. Farmers often use synthetic fertilizers that contain nitrogen, phosphorus, and potassium to provide the necessary nutrients for the crops. About 2 months into the growth process, wheat heads start to appear at the top of the stems. Each wheat head contains both male and female flowers on the same plant, allowing wheat to self-pollinate without the need for wind or insects. When the wheat plants turn a straw yellow or brown color, it's a sign that the crop is mature and ready for harvest. The plants will be fully dry, and the wheat heads will have a uniform golden color. The entire harvesting process is handled by machinery. The use of modern equipment allows American farmers to harvest tens of tons of wheat in just a few hours. The combine harvester plays a key role in this process, with each machine costing hundreds of thousands of dollars. It integrates three main functions: cutting, threshing, and separating the grain in one seamless step. The combine harvester can cover large areas quickly, saving both time and labor. The wheat grains are carefully harvested with minimal breakage or damage compared to manual methods. As the machine moves through the field, the cutter bar at the front slices the wheat plants close to the ground. Once cut, the wheat plants are carried into the machine via a conveyor belt, preparing them for the threshing and separating process. A rotating shaft system will separate the grain from the wheat stalk. They will then go through a screening machine to remove impurities and leave only the wheat grains. The grain is then transported onto the machine, ready for transport to the truck, and the excess straw is discharged directly outside. Once the grain tank on the harvester is full, the wheat grains are transferred to trucks or trailers to be transported to storage facilities. Wheat is typically stored in tall, cylindrical silos made of steel or concrete, capable of storing large quantities of grain. The silos protect the wheat from environmental factors such as rain, sunlight, and pests. Inside the silo, there is an elevator system that makes it easy to transport large quantities of wheat grain. After the combine harvester cuts and separates the grain, the leftover straw remains on the field. A baler is used to gather the straw and compress it into bales for easy transport and storage. Depending on the type of baler, the straw can be compressed into either rectangular or round bales. Straw bales can be used for various purposes, such as livestock feed or composting for organic fertilizer. After being harvested, wheat grains can be used as seeds or sent to factories for processing into flour. From flour, familiar foods like bread, croissants, and instant noodles can be made. Now let's take a tour of a flour mill, a bread factory, a croissant factory, and an instant noodle factory. First, let's visit the flour processing factory. Here, the wheat is passed through a cleaning system to remove dust, stones, husks, and other impurities. This process ensures the quality of the grain before milling. The cleaned wheat is then sent to the milling machines. In these machines, the wheat kernels are gradually ground down by rollers or hammer mills, producing coarse flour. During this process, the bran is separated from the inner part of the grain. After milling, the flour is sifted through filters to classify it by fineness. The fine flour is separated and prepared for packaging. Once the flour meets the desired quality, it is packed into bags or shipment to the market or stored in the factory's warehouse before distribution. Next, let's visit the bread factory. The main ingredients include wheat flour, yeast, water, salt, sugar, and fat. These ingredients are placed in large mixers to form a dough. This process activates the yeast and creates the gluten structure in the dough. After mixing, the dough is left to rise for about 1 to 2 hours, allowing it to expand and develop its soft, airy texture. Once risen, the dough is lightly kneaded again to release air and then divided into smaller portions according to the standard weight for each type of bread. A dough divider ensures the portions are uniform in size. The divided dough is then shaped into loaves on an assembly line, ready to be baked in ovens at approximately 250 degrees C, 482 degrees Celsius, for around 30 minutes. Once baked, the bread is golden brown with a crispy crust and a soft interior. After baking, the bread is cooled on conveyor belts. Once fully cooled, it is packaged in bags to keep it fresh for longer. Next, let's head to the croissant factory. The process here is almost identical to that of bread, with one key difference. The dough is rolled out evenly into thin sheets before being cut into smaller pieces and shaped into croissants. chickpeas are typically grown in areas with dry climates, loose, nutrient-rich soil, and warm weather. These little legumes thrive in conditions with moderate rainfall and low humidity, which help reduce the risk of pests and promote high yields. Chickpeas are not just an excellent source of plant-based protein, but they are also packed with fiber, iron, and essential minerals, making them a highly nutritious addition to meals. In the U.S., chickpeas play a significant role in both agriculture and the food industry. Additionally, they bring environmental benefits thanks to their nitrogen-fixing ability, which improves soil quality and reduces the need for chemical fertilizers. This makes chickpeas a top choice for sustainable farming systems. When harvest season arrives, the sprawling fields of chickpeas transform into a vibrant and bustling scene. It's not just a time for American farmers to reap the rewards of months of hard work, but also an opportunity to leverage modern technology to maximize efficiency and productivity in the harvesting process. Recognizing the right time to harvest is absolutely crucial. If harvested too early, chickpeas will retain too much moisture, making them prone to spoilage during storage. On the other hand, waiting too long can cause the seeds to become overly dry and hard, reducing their commercial value. Harvesting chickpeas in the U.S. relies almost entirely on modern machinery, particularly combine harvesters. These machines are designed to handle multiple tasks at once, including cutting the plants, collecting the beans, and removing the unnecessary parts like stems, leaves, and pods. They are built to operate efficiently on large fields, even those with slightly sloped terrain. During a harvest day, the combine harvester moves steadily and methodically down each row. The cutting blades at the front gently trim the plants, feeding them into the machine's internal system. Inside, the chickpea beans are separated from the stems and pods, then collected in a large onboard container. The leftover plant material, such as leaves and pods, is returned to the field as natural fertilizer. This process not only minimizes waste, but also enhances soil quality for the next planting season. Using modern machinery not only saves farmers time, but also significantly boosts productivity. A single combine harvester can cover dozens of hectares of chickpeas in a day, a task that would be nearly impossible for hundreds of manual laborers to accomplish. Additionally, these machines are equipped with advanced sensors that help farmers ensure precise seed separation and minimize losses during the harvesting process. In the food industry, the color and shape of chickpeas are crucial factors that determine their commercial value. Thanks to modern machinery, farmers can ensure that the beans remain intact and free from damage, maintaining their smooth beige color and uniform size, qualities that are highly desirable for producing products like hummus or chickpea flour. The chickpea harvesting process in the US is a clear example of how modern technology is being fully integrated into agriculture. Combine harvesters not only enhance production efficiency, but also reduce the physical burden on farmers, allowing them to focus more on improving crop quality. As a result, the US has established itself as one of the leading producers of chickpeas globally, playing a key role in meeting the growing demand for sustainable and nutrient-rich foods. The journey of harvesting chickpeas goes beyond simply transporting beans from the field to storage. It reflects the creativity and dedication of American farmers in connecting the land, technology, and communities. With continuous advancements in technology and farming practices, the chickpea industry will remain a shining example of high-tech agriculture in the United States. After harvest, chickpeas are transported to processing facilities where they are cleaned and sorted. Modern machinery removes impurities like branches, leaves, and small stones. The chickpeas are then dried to reduce moisture levels, ensuring the quality of the beans during storage and processing. Beans that meet quality standards are packed into tin cans filled with brine or natural soaking water, allowing for long-term preservation and maintaining their flavor. In addition to canned chickpeas, they are also processed into hummus, chickpea flour, or pasta, and packaged in plastic containers or sealed paper bags. Chickpeas that do not meet quality standards are repurposed as livestock feed, ensuring resources are used efficiently and contributing to a sustainable supply chain. This process supports both domestic consumption and export demands effectively. Harvesting chickpeas is impressive, but have you ever wondered how American farmers plant this highly nutritious crop? Let's dive into this fascinating journey right now. Chickpeas are planted on vast fields, covering hundreds or even thousands of acres. The entire planting process is carried out using modern machinery, which boosts production efficiency, optimizes yields, and minimizes reliance on manual labor. Chickpea seeds are sown using automatic seed planters. These machines are programmed to plant the seeds at the ideal depth, typically 1 to 2 inches below the surface, and with a spacing of about 6 to 8 inches between each seed. This setup ensures that the chickpea plants have enough space to develop strong roots and receive ample sunlight for healthy growth. During the growth phase, chickpea fields in the US are closely monitored using advanced technology. Modern irrigation systems such as drip or sprinkler irrigation deliver water precisely and efficiently, ensuring that chickpea plants, already drought-tolerant, grow robustly. By applying cutting-edge technology, chickpea farming in the US achieves high yields and superior quality, meeting the growing demand in global markets. This approach is a clear example of sustainability in modern agriculture. Typically, oat plants require about 90 to 120 days after planting to reach the harvest stage. When the lush green fields of oats transform into a stunning golden hue, it signals that the grains on the stalks have ripened perfectly and are ready for harvest. This process not only demands precision, but also requires a seamless blend of advanced technology and the expertise of American farmers. When the time comes, the powerful combine harvesters are put into action. These machines are specially designed to perform multiple tasks simultaneously: cutting, threshing, and handling the stalks. At the front, a row of sharp blades cleanly cuts through the oat plants as the machine moves forward. Inside, the system efficiently separates the oat grains from the stalks using sieves and blowers. The harvested grains are then collected in an integrated storage bin, ready for transport. Meanwhile, the stalks are shredded and evenly spread back onto the fields, serving as a natural fertilizer to enrich the soil and maintain its fertility for future crops. One of the highlights of this process is its precision and efficiency. made possible by advanced technology. Modern combine harvesters not only work quickly, but also minimize grain loss during harvesting. With the support of GPS systems and smart sensors, farmers can monitor harvest progress and yield in real time. This data is invaluable, not only for optimizing the current harvest, but also for improving farming practices in the future. Once the storage bins on the combine harvesters are full, the harvested oats are transferred to specialized trucks. Many large farms in the U.S. use automated transfer systems, allowing oats to be seamlessly moved from the harvester to the truck without stopping. This saves time and ensures a continuous workflow, which is especially crucial on vast fields spanning thousands of acres, where every second matters to avoid adverse weather conditions that could jeopardize the crop. Compared to traditional manual harvesting methods, modern machinery not only reduces labor costs, but also significantly boosts productivity and enhances the competitiveness of American agricultural products in global markets. Beyond improving efficiency, these machines play a crucial role in environmental protection. Advanced harvesters are designed to save fuel and minimize carbon emissions while making full use of the oat plants. The shredded stalks are not wasted, but are repurposed directly on the fields as natural fertilizer, replacing the traditional practice of burning straw, which contributes to air pollution. Trucks loaded with freshly harvested oats from vast fields roll into the processing plant, carrying the golden grains of the season. Here, the oats are unloaded onto a conveyor belt that leads directly to a vibrating cleaning machine. This machine acts like a meticulous inspector, removing dirt, stones, and other impurities left from the harvesting process. Once cleaned, the oats continue their journey along the conveyor belt, heading toward the dehulling machine. The dehulling machine plays a crucial role in removing the tough outer shell that encases each oat grain. These husks are not wasted but are collected and repurposed as cattle feed, ensuring an efficient and sustainable use of resources. Meanwhile, the dehulled oats, the most valuable part, continue their journey along the conveyor belt to the steam kiln. Here, the oats are treated with high heat and steam, a process that not only enhances their flavor, but also ensures consistent quality and extended shelf life. After leaving the steam kiln, the oats are sorted by size and color using advanced automated scanning systems. Larger, uniform grains are directed to machines for rolling and cutting. This process creates instant oats, a popular choice for quick and convenient breakfasts. Once rolled thin, the oats are packaged on site at the factory, ready to be stocked on store shelves and delivered to consumers. Meanwhile, smaller oat grains that don't meet the standards for instant oats are sent to the grinding machines. These machines process the grains into fine oat flour, a versatile ingredient perfect for baking and nutritious meals. Once ground, the oat flour is carefully packaged into bags or larger sacks, ensuring easy transport and long-term storage. Rice is a staple food worldwide, and in the US, it comes in several varieties, primarily long grain, medium grain, and short grain. Long grain rice, like the popular jasmine and basmati, is slender and stays fluffy when cooked. Medium and short grain varieties are plumper and stickier, making them ideal for dishes like sushi or risotto. The appearance of rice varies depending on the variety, but in general, it is found in shades of white, brown, or even black and red, depending on whether it is processed or left whole grain. Rice plants thrive in warm, humid climates and require plenty of water. Unlike crops that can withstand dry spells, rice needs constant moisture, which is why it is often grown in flooded fields called paddies. The best growing conditions include temperatures between 70 to 100 degrees Fahrenheit and well-drained, loamy soil with a pH between 5.5 and 7.5. These conditions help ensure the plants develop properly, allowing them to produce healthy grains. In the US, rice is mainly cultivated in Arkansas, California, Louisiana, Mississippi, Missouri, and Texas. Gone are the days when farmers had to cut rice by hand with sickles and spend days processing it manually. Rice harvesting in the US has evolved into a highly mechanized and efficient process, primarily using combine harvesters, large and powerful machines that can complete in minutes what previously took farmers days to accomplish. These machines not only cut the rice, but also thresh, separate, and clean the grains in a single operation, making them indispensable in modern rice farming. The introduction of combine harvesters has dramatically transformed rice production, increasing efficiency, reducing reliance on manual labor, and ensuring that rice can be harvested quickly before adverse weather conditions impact the yield. A combine harvester is a sophisticated piece of machinery with multiple essential components, each serving a specific purpose to ensure a seamless harvesting process. At the front of the machine is the header, a critical attachment responsible for cutting the rice stalks and feeding them into the harvester. As the stalks are drawn in, they enter the threshing drum, which plays a key role in separating the grains from the stalks and husks. This stage is crucial, as it allows the grains to be detached efficiently without damaging them, ensuring the maximum yield from each field. Once the grains have been separated, they pass through sieves and a cleaning system, where any remaining debris, broken husks, or unwanted materials are filtered out, leaving behind clean, high-quality rice. This meticulous process ensures that only the best grains proceed to the next stage. The harvested rice is then stored in a grain tank, which temporarily holds the rice before it is unloaded into waiting trailers or trucks. This unloading system allows for a continuous harvesting flow, ensuring that fields can be cleared efficiently and promptly transported to processing facilities. One of the most significant advantages of using combine harvesters is their ability to increase harvesting efficiency by up to 50 times compared to traditional manual methods. This dramatic improvement not only saves farmers time, but also reduces labor costs and minimizes grain loss. With rice being such a vital staple food, the ability to harvest quickly and efficiently ensures that more rice reaches processing plants, meeting the demands of both domestic and international markets. The integration of industrial machinery into rice farming has revolutionized the industry, making large-scale production feasible while maintaining high standards of quality. In addition to efficiency, modern combine harvesters incorporate advanced technologies that optimize yield while minimizing environmental impact. Many of these machines are now equipped with GPS tracking systems, which enable farmers to precisely map their fields and follow optimized harvesting patterns. This precision reduces waste, prevents overharvesting in certain areas, and maximizes the use of available land. Furthermore, many combine harvesters feature adjustable cutting heights and grain loss sensors, ensuring that every stalk of rice is harvested effectively while reducing unnecessary waste. Beyond their immediate harvesting capabilities, combine harvesters also contribute to sustainability in agriculture. By streamlining operations and reducing the need for extensive manual labor, these machines allow for more controlled water and soil management, ensuring that rice paddies remain fertile for future planting seasons. With innovations such as automated moisture detection systems, farmers can make informed decisions on the best times to harvest, preventing spoilage and maximizing the longevity of their crops. The adoption of such cutting-edge technology continues to push the boundaries of agricultural efficiency, positioning U.S. rice farming as a model of innovation and sustainability. In an era where global food demand is increasing, the ability to produce rice efficiently while conserving resources is more critical than ever. Farmers who incorporate these advanced techniques not only improve their own profitability, but also contribute to a stable and sustainable global food supply. Once rice is harvested, it doesn't go straight to store shelves. Instead, it undergoes several processing steps in factories to make it safe and appealing for consumers. The first step in processing is cleaning and drying. Freshly harvested rice contains moisture and impurities like dirt, stones, and husks. Large industrial dryers reduce moisture levels to prevent spoilage. The drying process is crucial because improperly dried rice can develop mold or spoil before it reaches consumers. After drying, the next step is hulling, where the outer husk is removed, leaving behind brown rice. For those who prefer white rice, the process continues with milling, where the bran layer is polished off, revealing the soft, white grains underneath. This process is done carefully to ensure that the grains remain intact and maintain their quality. However, milling reduces the nutritional content of the rice, which is why some manufacturers enrich white rice with vitamins and minerals before packaging. The next crucial step is sorting and grading, where high-tech machines use lasers and sensors to remove broken or discolored grains, ensuring uniformity. This step ensures that only high-quality rice makes it to consumers. Finally, the rice is packaged and stored in temperature-controlled warehouses before being distributed to markets. Some rice is processed further into rice flour, rice bran oil, or instant rice products to meet the diverse needs of consumers. Factory processing ensures consistency, food safety, and efficiency in the supply chain. With rigorous quality control measures in place, American rice producers can guarantee that their products meet both domestic and international food safety standards. This level of precision ensures that the rice sold in stores remains fresh, nutritious, and free of contaminants. Before farmers can even think about harvesting, they must first prepare the land and plant rice correctly. Rice farming begins long before the first green shoots appear in the fields. The first step is soil preparation, where farmers plow and level the fields to create a smooth surface for planting. Water management is crucial, so they set up irrigation and drainage systems in advance to maintain proper moisture levels. Farmers employ two primary planting methods: dry seeding and water seeding. In dry seeding, seeds are planted in dry soil and later flooded with water. This method allows for better weed control and makes the rice more resistant to lodging, falling over due to wind or rain. In water seeding, pre-germinated seeds are directly sown into flooded fields, a method that helps suppress weeds naturally but requires precise water level management. Once planted, rice fields require careful maintenance. Fertilization and pest control play a significant role in ensuring a healthy crop. Farmers use a combination of organic and synthetic fertilizers to provide essential nutrients. They also employ integrated pest management techniques to keep harmful insects, weeds, and diseases at bay without excessive chemical use. Throughout the growing season, water management is carefully controlled to maximize yield while minimizing environmental impact. With the right preparation, rice plants grow strong and healthy, leading to a bountiful harvest when the time comes. The use of modern agricultural techniques has allowed American farmers to optimize rice production while maintaining environmental sustainability, ensuring that the U.S. remains a competitive player in the global rice market. Harvesting 9.97 million tons of rice in the U.S. is no small feat, and it requires a combination of advanced technology, skilled farmers, and efficient processing systems. And there you have it, the story about harvesting and processing the mighty rice in America. Hope you'll like it. Don't forget to like the video and subscribe to our YouTube channel for the next interesting videos. See you next time. Goodbye.